Let us deal with the very last differential type of differential equation that you're going to encounter during the course, which is system of differential equations. Usually the systems are very hard to solve, or sometimes you can't even solve them by with analytical methods, these methods that we showed you during this lectures. But this is specific one that you're going to encounter in the course is ridiculously simple. Let me show you what does it look like. Okay, so it's a system of differential equations. So here there are two differential equations. Let me write them out. We have second derivative of f plus first derivative of g plus f. Okay, sorry, minus f equals 0. That is the first differential equation. You can see that there are two functions, f and g, in here. So if you want to find the solution, you have to find both of them. There is another one. So there are two, essentially there are two unknowns, that are like two functions we're looking for, but this is only one equation. We need another equation. And there it is. That's the second differential equation. Second derivative of g minus first derivative of f equals 0. You see, this is a system. There are two differential equations and there are two unknowns, g and f. We're going to solve for them. G and f are both defined, let's say, on this domain, 0 to 1. And the boundary conditions are as follows. F of 0 equals 0. G prime at 0 is equal to 0. And what else do we have? F at 1 equals 0. Wait a second. G prime at 0 is equal to 2. Sorry. Is equal to 2. Oh, wait a second. I can't see anything. There we go. And G at 1 is equal to 0. Alright? So let's take a look at it. Let's see how many boundary conditions I have. I gave you 4 of them. But wait a second. The order of the differential equation was 2. That's the largest derivative. But note that we have two equations here. There are two functions. So for one of them, the largest order is 2. The largest derivative is 2. Sure. So this one is second order. So we need two boundary conditions. But there is another equation too. There is another differential equation too. This one is also second order. So we need 2 more. So essentially we need 4 boundary conditions to figure out the solution. Okay, so that's basically it. So I said it is ridiculously simple to solve this specific system of equation. Let's see, why is that? Okay, see, I want to do something. What I would like to do is to decouple these two equations. Right now they're coupled. In each one of them we have g and f. I want to do something to end up with one equation at least which only has f or g. Okay, let me see how we can do that. For instance, here in the equation on top, I have g prime minus f. On the bottom, I have the same thing, except for that it's derivative of this guy. This guy is the derivative of these two terms. So what if I take the derivative of the entire equation on top, this guy, then these two terms would be identical to these two terms. What I can do is to subtract this fellow from the top, and I will end up with an equation which doesn't have these two. It will only have f. Okay, let me do it. Let me see. Let's take a look at it in action. So instead, I'm going to take the derivative of the first equation. So f double prime will become f third derivative of f plus g prime would become second derivative of g, and f becomes, and there it is, minus first derivative of f. That's equal to 0. I said I want to subtract. I have this fellow here, the second equation. I'm just going to write that identically. and I would like to subtract the first one from the second one. See how does it work. So this thing comes down, third derivative. Oh wait a second, I can't see. There we go. So this fellow comes down straight away. And let's take a look at it. This guy would do minus g second derivative plus g second derivative, so these two cancel out. I'll have 0. What about here? Same story here. This f prime would cancel out too. So I'll have, let's say, minus 0. And 0 minus 0 is just 0. So let's take a look at it. Now it's like I have a new different system of equations. By the way, I hope you guys know that you can always, when you have a system, you can always subtract any multiple of one equation with from the other one. That's allowed. You can really do that. So that's what we did here. We just subtracted the second equation from the first one. That's perfectly allowed. All right. So now I ended up with another system. This is now decoupled. Let's see how does it look like. The first equation is the third derivative of f equals 0, and the second equation is second derivative of g minus f prime equals 0. There we go. That's now decoupled. So we could go ahead and solve this first fellow, this guy on the top first. So if we solve for this, we will have a family of solutions of f. F will be equal to something with all the unknown constants and everything. I will just drag this f and insert it right into this second equation, and I will have g double prime equals something, the value of the derivative of f. This is another differential equation. I can solve it. That's identical to the first exercise that I gave you. You can solve this fellow and find g, family of solution of g. Okay, guys, I always write down family of solutions so that you know that you're not going to insert the boundary conditions yet. You're going to do it after everything is known, just so that we're not confused by anything. So here we solve this differential equation. We find family of solution of f. We insert f in here. We will have another differential equation. We solve it, and we find family of solution of g. Now we have g and f, okay, the family of solutions. We will insert the boundary conditions, these guys, in each one of them, and find the solution for f and g. Note that we ended up with two differential equations. One of them was just like that, and the other one was just like that. Okay. And the exercise for you guys is to find the solution for f and g. Find the solution for f and g, and just like always, plot them. It's always good to plot the stuff. You can actually see what's going on there. Alright, that's it.